This one's going to be a little bit different. This time we're talking about an archer who is releasing an arrow from a bow 10 feet above the ground. So notice this is not being launched from ground level. The arrow leaves the bow at a 20-degree angle from the horizontal, and its initial speed is 180 feet per second. Part A wants us to write a set of parametric equations for the path of the arrow. Well, I've written them down here again so that you have the model, and I would keep this in your notes. X is V naught cosine theta t. Y is h, that's the initial height. V naught, that's our initial velocity. Sine of our angle at which it's launched, t minus 16t squared. So for part A, when I write my parametric equations, x is supposed to be the initial velocity, which it says was 180 feet per second. Speed and velocity are essentially the same in this situation. Times cosine of the angle theta. So cosine of the angle it was launched was 20 degrees, t. Okay. Next, for our y value, we have y equals h, the initial height. So it was launched from a height of 10 feet. So we have 10 here, plus the initial velocity or speed, which again was 180. Sine of theta, so sine of our angle 20 degrees, times t minus 16t squared. Now again, the calculator I'm using you have to use radians. So I'm going to convert my degrees here to radians for my equation to put into my graphing calculator. If you have a handheld one, you can probably adjust that. So I want to convert 20 degrees to radians. So we multiply by pi over 180. 20 goes into 189 times. So I get pi over 9. So if you need to write this in terms of pi, my equations would be x equals 180 cosine. In my calculator, I'm going to have to put parentheses around the pi over 9 and then put my t. And y would be equal to 10 plus 180 sine. Again, here for my calculator, I would have to put parentheses around pi over 9 t minus 16t squared. Okay, so those are our equations, and we are ready to go to our calculator. Okay, so here I am again at this graphing calculator. Notice in my mode I chose parametric so that it gave me an x and a y in terms of t. I'm just going to clear these out so I can put my equations in. And remember, our equation for x was 180 cosine of pi over 9 times t. And our y value was 10 plus 180 sine pi over 9 t minus 16t squared. Okay, so just do a quick double check. Make sure you have everything typed in there correctly. And then go ahead and push plot graph. Okay, now notice nothing is showing here. I definitely need to work on my window. So my minimum, I'm going to leave at -5. And again, I'm going to start at about 200 just in case for my x. My y minimum I'll leave at -5, and my maximum I'll put at about 150. And then we'll adjust. For my t's, I'm going to go from 0 to 10 again. Update. So see, I can see the projectile going up. I can't quite see its peak, and I can't see where it hits the ground. But I can see I probably have a high enough y for now. I'm going to change my x range so that I can extend this out further. Remember, x is our distance sideways. So I'm going to put that at 400 and update. Still not enough. I'm going to put it at 800 and update it. There we go. 800 was plenty. Notice here is the 750 mark. It looks like I can maybe bring it back to 600. No. Okay, 650. So I'm just playing with this calculator window till I get something that works out best. Okay, 700. You see, I can see it coming down through. All right. Now notice my y maximum is way too high. It doesn't even get to 75. So I'm going to change my y maximum to 75 because the closer I am, the easier this is going to work for me, the better it'll work out. Since I don't have a trace function on this calculator, the easier it'll be to see my maximums and minimums. Now, let's go back and see what were we asked to find for this. Well, we were asked to find the maximum height. We were asked to find the range. And on this one, you're also asked to find out how long was the arrow in the air. So how much time passed between here and when it hits the ground. And we'll talk about how to figure that. Okay. Now, if you have a handheld calculator, it may trace the t value for you. It doesn't on this one, but we'll talk about how to do it. All right, so what was our maximum height? So we can see the path of the projectile. It peaks right up here, which looks like here's 75 and here's 50. Okay, so we have 50, 55, 60, 65, 70, 75. So these are by fives. 55, 60, 65, 70. So it's not quite to 70. It's above 65, closer to 70. So again, it kind of stinks that I have to just estimate this. Okay, but I can see it's pretty close to 70. I would estimate that to be about 69 feet. So my maximum height, go ahead and write down, is 69 feet. Now we need to know the range. What's the range, or how far did the arrow travel before it hit the ground? So that would be, this is our ground here. How far did it go? Well, here's our 500. And each of these appear to be by 50s. So this is 500, 550, 600, 650, and then the board end here is at 700. So it's between 650 and 700. Okay, I would say that's a little over halfway between 650 and 700. So 675 would be right in the center there. I would say this is about 676 or 677. Okay, let's go ahead and put 677. So our maximum height was at 69 and our distance it traveled was at 677. Okay, we're going to go back to our paper now, and we're going to go ahead and write in our answers. It says, assuming the ground is level, find the distance the arrow traveled before it hit the ground, and we found that our range, or our distance it traveled before it hit the ground, was 677 feet. Again, if you have a trace function on your calculator, that probably worked out more exact for you. C, use a graphing utility to graph the path of the arrow and approximate its maximum height. So we approximated the maximum height using our graphing utility, and we found that it was at about 69 feet. Remember, our maximum height we said was about 69 feet. And D says, find the time the arrow was in the air. So how long did it take from being launched until it hit the ground? Well, we knew it hit the ground at 677 feet, or when X was 677 feet. So what we do here is we take our 677 feet, that's our X, and set it equal to 180 cosine 20 degrees, or pi over 9 if you prefer. Okay, T. This was our X value, so we want to know what was T, how much time had passed when X, our horizontal distance, was 677. So you just go ahead and take your calculator and do cosine of 20 degrees and then multiply by 180. Okay, and when we do that, we end up with our 677 still is equal to 169.144 about T. And then to solve for T, I'm just going to divide both sides by 169.144. And that will tell me how much time had to pass for that arrow to travel a horizontal distance of 677 feet. And I get about 4. Remember, our time was in seconds, so it took 4 seconds for that arrow to travel that horizontal distance. Again, the horizontal distance it traveled before it hit the ground was 677 feet. The maximum height was 69 feet, and it took 4 seconds to travel.